Okay, let's now continue this survey. And by the linear multiple objective network flow problems, MONFPS. And one of the first algorithms was developed by Maillot and Puri, is a bicriteria network flow problems, and published in the Cahiers of Zero in Belgium. And what they presented was an algorithm for a network, and this network all the capacities on the edges were all equal. I don't know why he considered all the capacities equal, but for some reason. And then one of the things that he used, and that this time more or less people use the out-of-filter algorithm, which is a kind of primal dual algorithm. And this algorithm, we did some tests. They have an example, and for the example they present only 3 non-dominating solutions. We can find 4. So this algorithm, something is missing in the algorithm. Then Lee and Pulat, 91, also worked on bicriteria network flow problems for the continuous case for the linear one. The problem is they consider that every solution in the decision space was an extreme solution in the decision space should be an extreme solution in the objective space, and this is not true. And so the algorithm fails for this reason. Then they try to modify the algorithm, considering they figure out that the problem was the algorithm was erroneous, and a lot of people criticized the algorithm, and they try to make some improvements of the algorithm in this paper, Pura et al. 92. But again, some important issues are missing, and it could identify extreme points, but not all. Okay. Then Cedeño and Gonzalez Martin studied also the bi-objective minimum cost flow problem with simplex methods, but also they try to improve the first algorithm by Pulat. But in this paper, there are also some solutions that cannot be found. And again, in 2003, they proposed an alternative method for solving or to solve the biology minimum cost flow problem. And here they used a kind of Lagrangian method to incorporate the other objective. And they should be able to compute, even with the Lagrangian structure, to compute all the solutions, because this is equivalent to parametric programming. But the problem is that they use the algorithm just for specific conditions. They start to incorporate a kind of local search in this case. Okay, now for the integer case. Integer case corresponds to what I showed you in the figure, and we have not only supported solution, but unsupported one. The unsupported ones are the solutions that are non-dominated, and they are located inside the convex out of all these points. Okay? Lipola 93, bicriteria network flow problems. The method was divided in 2 phases. First phase compute all the supported solutions, and the second phase on the unsupported ones. But they used the wrong algorithm for the supported solutions, so at the end they could not compute all efficient and non-dominated solution. I will tell in terms of non-dominated solutions because in general they work on the objective space. And Matthias Ergot in 1909 in Portuguese Journal of Operation Research published an article in teacher solutions for multi-criteria network for problems. And this article is quite well, but it fails because at the moment he used also the technique by Puller, Lee and Puller, and of course for more than two problems we cannot complete all the solutions. Then I proposed in 2000 an integer B-criteria network flow problem, and it was by solving a sequence of epsilon constant problems and using branch and bound. And since this time, people didn't believe that I didn't destroy the structure of the network. Because I'm using branch and bound, you should destroy the structure of network. And we will see that it is not the case. And this was improved by myself and Augusto and published now. But this algorithm was correct. Simply we did more things that were necessary. And now we removed and implemented the algorithm. Now, in my opinion, this was the first method able to compute all the solutions for the bi-criteria problem. Then another method by Cedeño, Nolan, Gonzalez, Martin for the objective integer minimum cost flow problems. The algorithm also fails can compute all the points in the objective space, but it's not possible to compute, for example, in between two extreme points. Because as you see in my third algorithm, there are some solutions that can be easily we can forget these solutions, and they didn't consider all the non-dominated points, but the extreme points are correct, and the other points false. This work was a manuscript filtering algorithm, and one master student implemented this algorithm, and it was based on the K-best flows by Amacher from Germany. And this also can solve the problem. It's very, in fact, in the worst case, we can compute all the solutions of a network, which is a very hard task. And but can solve the problem. And very recently, Wright and Ergot, Andrea Wright and Matthias Ergot, improved this method. This is only an improvement of the method, and make some tests and publish the paper in Computers and Operation Research. Okay, now for approximative algorithms. It's very, very easy. The approximative algorithms basically there are sandwich algorithms. They put a curve, and then there is an inner approximation by a piecewise linear function, and an outer approximation by another piecewise linear function. And then the algorithm changes it with how to measure the error or how to design this inner and outer approximation. So this is Burkhardt and other. This is the first one. Then Gunther Ruf, the same, but they change the measure of the error. This is the same kind, and they change another kind of rules, but the technique is always a sandwich algorithm. We can do inner and outer. Another kind, this is for continuous. And then here is a different type of algorithms based on the concept of epsilon optimality. Other algorithms, they try to approximate integer part. Some approximate by only by computing some solutions, some supported solutions. This one is use PNAS, but PNAS is for linear programming problem. Then they have a strategy to compute a closer integer solution, but this was an integer solution. We don't know if it is non-dominated or not, even for 3 criteria. And recently, also some algorithms, these are called box algorithms. They approximate the set value using boxes. We are working also with Horst and Stefan for developing another kind of this family of algorithms. Now another algorithm called Multicriterio network for programs published in Cybernetic Information Technologies, and the second one by Nikolova. And also these 2 algorithms approximate some parts of set domination solutions, not the whole. And one of this is interactive. The only one I know is this one that is from my PhD thesis, and was published in JAWS. I mean, and this one was designed as an interactive scheme with in different regions. There are some concepts, nice concepts, but the way I solved it destroyed the structure of the network. So it's not so, in terms of elegance of the technique, it's not so good. The concepts, I think, are more or less good, but not perfect. Okay, the first contribution here. This one it's a primal dual for minimum cost of control. We don't know any other primal dual for e-objective network flows